things, and then we're going to do the lab. These are just very small things, okay? But they are part of the curriculum, so we are covering them. So, if you're still on your phone, you want to get off your phone, okay? And you want to be on page 65. And if you don't have a book, someone can borrow mine. It's right there. Help yourself. H3O plus. Now, first of all, before we go into anything on H3O plus, please tell your partner what the name of that ion is. H3O plus is the hydronium ion. So the hydronium ion is the strongest acid that can exist, and there's a reason that's double underlined in water. And there's a reason that's double underlined. And that is because any acid that is stronger than H3O plus will ionize 100%. And therefore, how much of it will be left? 0%, okay? So 0% of that acid exists in water. So say, for example, we had HCl. Yes? Well, all of the HCl is going to react with H2O. And you'll end up with H3O plus Cl minus. And how much is this? We have now 100% of that. How much do we have of this? We have none. Does that make sense? Now, interestingly enough, if you had a different solvent than water, like let's say ammonia was our solvent, and this part here, like this part isn't really testable. It's just sort of for interest's sake. If the solvent was NH3 instead of H2O, any acid stronger than NH4 plus cannot exist in ammonia. Okay, this is not really on your test, this bit here, okay? Okay, so if we take a look at our data pages, get your data pages out if you don't have them out already. If we look at the hydronium ion, it is up here, yes? And so it exists in water, and it will exist in equilibrium with H plus and H2O, yes? Whereas all the rest of these don't exist in water because they all go to completion, yes? Now, if our solvent instead were ammonia, and like I said, this part you don't really need to understand, but if we go like this, we're like, okay, here's ammonia. NH4 plus would be the strongest acid, and everything above ammonium ion would be a strong acid. Everything up here, H3PO4, Al, H2O6, those would all be strong acids, which is kind of bizarre, but that would be if ammonia was the solvent. What do you think is the strongest base that can exist in water? What is the strongest base that can exist in water? Tell your partner. Take a look at your chart. Strongest base that can exist in water. Now remember, up here, when we were looking for the strongest acid that can exist in water, we had the hydronium ion. Yes? Who is the strongest base that can exist in water? Nope. OH. Yes? You're just backwards. Yes? So OH minus is the strongest base because if you have, for example, O2 minus, I wrote this yesterday, so I guess I'm not having to write it again. And I've written it going backwards because you can see it. That's the direction that they go on this chart. O2 minus plus H2O all goes one way. And what do you get? You end up with OH. NH2 minus, which is also a strong base, reacts with water. And what do we get? We get OH minus. So that is the strongest base that can exist in water. O2 minus is a stronger base, but does it exist in water? No, because it ionizes 100% to form hydroxide. NH2 is stronger than OH minus, but does it exist in water? No. Same thing for these acids up here. HCl is stronger than H3O plus, but does it exist in water? No, it all comes apart. Yes? It has nothing to do with solubility, no. No, it just has to do with the fact that this just completely dissociates and you'll end up with HCl plus H2O. All goes one way and you end up with H3O plus and Cl minus, and there's none of this left and you only have that left. Yeah? Yeah. Okay, and that's all you need to know about the leveling effect. Okay? And if you're like, if the question asks, what's the strongest acid that can exist in water? Bam. What's the strongest base that can exist in water? Okay. Bam. Okay, you don't need to know much more about it than that. You don't need to know that whole thing with ammonia being the solvent. That's just, like a little bonus for your brain. Okay? The second thing we need to learn about is, where did I put it? 4.1H. So we are on page 57, I believe. Page 57. And we skipped over this. I love my pen. It just does such weird things. 57, there we go. And this has to do with being able to recognize if something is a base or if it is an alcohol, because both bases and alcohols both have OH in the formula. So bases and alcohols both have OH in, I'm going to get rid of that big page number, the formula. But you need to be able to tell the difference because one of them in water is going to conduct electricity and one of them is not. One of them is going to act as a base and will react with acids, and one of them will not. So how can you tell that you have a strong base? Well, you need to have the metal hydroxide. So you're looking for a metal. You could also have NH4 because remember NH4 is also an ion. And if we look at our metal hydroxide, in between the positive ion and the negative ion, we have an ionic bond, yes? An ionic bond. And what can water do with ionic bonds? It can break them. Water can break ionic bonds. Not if they're too strong. That's where you end up with things that are not soluble. But for the most part, water can break them. I guess I should write ionic bonds. Anyone know why water can break an ionic bond? Have a chat with your neighbor about that. Why can water break an ionic bond? Have a little chat, and then I'll come to you. Okay, Sarah, tell me about why you think water can break ionic bonds.
Because of polarity in hydrogen and oxygen.
Because polarity in hydrogen and oxygen. Water is polar. Okay, what we've got is we've got the slightly negative oxygen, and then the hydrogens are slightly positive. So what they can do is they can go in and substitute, they can go in and surround the Na and pull it away from the OH. So what you'll end up with is Na plus. Which side of the water would face the Na plus, the negative or the positive? The negative. So I'm actually going to leave that one there. It's almost in the right place. Okay, so we've got our negative facing the Na. And then with our OH minus, which end of the water would face the OH minus? The positive. So we would have those positive hydrogens facing that. And that's why it can pull them apart. Is good? Okay. There are no shared electrons here. Yes? If, on the other hand, we go and look at an alcohol, what we have in an alcohol is, oh, actually, before we go there, I should say that this thing here is the hydroxide ion. Whereas this thing over here attached by a covalent bond to the carbon, that's not a hydroxide ion. That is called a hydroxyl group. That is a hydroxyl group. Can water break covalent bonds? Nope. water cannot break. Now, how are you going to tell the difference between a base and an alcohol? What does a base have in front of the OH? Either a metal or NH4. Okay? So this right here has to be a metal, or it has to be NH4. And that means if you have metal or NH4, you have a base. You have the hydroxide ion, you have a base. It will dissociate in the water. And it will be an electrolyte. So you can see here's all our bases. We've got our metal, 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 and we have our hydroxide, hydroxide, hydroxide. I should, just for completeness, I should have NH4OH. You would end up with NH4 plus because that's also an ion, and OH minus. So all of those are your bases. What do you notice about the alcohols? No longer do you have a metal or NH4. What do you have? You have some amount of carbons, some amount of hydrogens, so CXHY, and then you have OH. Just be careful not COOH. What would you have if you had COOH? That would be an organic what? Organic acid. Because alcohols are also organic compounds, but they're not organic acids. Okay, the thing that makes them organic is the CXHY bit. Okay, and so you should know that these are non-electrolytes. And when they dissolve in water, they don't come apart, they just mix with the water. So you get an even distribution of both types of particles, all right? But they don't split apart. So you start with CH3OH, which is liquid, which is just pure, and then it becomes a mixture of those CH3OH molecules with water molecules, aqueous. You start with pure, what's this one? Pure phenol, and then you have phenol mixed with water. You start with pure ethanol, ethanol mixed with water, but the ethanol molecules are still intact. They don't split apart. And that's just about it, okay? So those are the only two things that I hadn't covered that would be on your test on Thursday. Are we good with those? All right. So today we're going to talk lab. Hopefully you'll be able to finish this before the end of the day today, okay? Is there anybody who was away and did not get this titration review sheet? We all got it? Okay, I'm going to put it up here. I will also put the review quizzes up here in case you didn't get them. Okay, so if you didn't get these, come help yourself. And if there's anyone who did not get the overall review, or if you want an extra copy, it is here. Okay? Overall review. Okay. Stop recording. Stop recording. Hi.
Is this a typo?
Probably, yes, that is a typo. That definitely looks like one. Why will it not stop recording? Oh. No. Okay.